Welcome, ladies and gentlemen. So what I'd like to do is show you how to solve rational equations. So basically, when solving rational equations, the main important thing I want you to get in your brain is eliminating the fraction. Basically, eliminating that we have a numerator and a denominator. Because to solve our rational equations, we got to solve for x, just like solving any other equation. But we got to get our variables off the denominator. And we can do that by multiplying by our LCD. So you can see in this one, we actually have a proportion. And I know some students might automatically think cross multiplication. And cross multiplication is fine, and you can use that process. However, I am not going to be using cross multiplication for the bottom two. So I just want you to get in the mindset of thinking of just find the LCD and multiply everything by your LCD. So in this first case, you can see the LCD between 3x and x plus 2 is just going to be the product of them two, which is going to be 3x times x plus 2. So what I'm going to do is I'm going to, again, multiply my whole equation by 3x times x plus 2. Well, I have basically two expressions here. So both of these I'm going to multiply by my LCD. And I'm going to multiply them in the numerator, 3x times x plus 2. Because remember, whenever I have an equation, as long as I multiply the same equation on both sides, or I multiply everything, like for instance, if I have x equals 2, and I multiply both sides by 4, as long as I multiply both sides and everything by there, I have 4x is equal to 8. Well, I know the answer is still 2. All I did is I produced an equivalent equation. So multiplying by both sides by your LCD is not changing your solution at all. But what it's now allowing me to do is now apply the division property. Because the division property says if you have a term in the numerator and a term in the denominator, they're going to divide to 1. Now I have x plus 2 in the denominator, x plus 2 in the numerator, and they're going to divide to 1. Therefore, I'm left with 9 times x plus 2 is equal to 4 times 3x. Now I can apply distributive property here. So I get 9x plus 18 equals 12x. Now we just have a simple equation that all I need to do is get my variable, solve for my variable on the same side. So I'll solve for the variable on the right side. So I'll subtract a 9x on both sides. I get 18 is equal to 3x. Divide by 3, divide by 3. X equals 6. Now, the next thing we want to do is whenever we're solving irrational equations, we want to make sure we go back to our solution and make sure our solution does not make our denominator 0. Because if it does, then the solution is going to be extraneous. Well, in this case, if I plug 6 in for x, it's not going to make either of my denominator 0. So therefore, this checks out. OK, so now going into the next example, again, we're going to be thinking of the same thing. But we always don't want to jumpstart what we believe the LCD is until we can simplify our expressions. And you can see here, I can simplify this 3x minus 6. I can factor out a 3. That's going to leave me with an x minus 2. And here, I can factor this into a difference of two squares, x minus 2 times x plus 2. So in reality, by looking into my denominators, my denominators both have an x minus 2, but then they have an x plus 2 as well. So therefore, if I'm going to find my LCD, which I'm going to move here and just use a different color, I'll use blue. My LCD for this problem is going to be x plus 2 and x minus 2. Because both of my denominators share x minus 2, and they share x plus 2. So now, following the same operation I did before, I'm going to multiply both of my terms on both sides by my LCD. I'll just get that out of the way here. So I have x plus 2 times x minus 2.
Rosa, please call the main office. Rosa, please call the main office.
So now, again, we can apply this division property here. So over here, you can see my x minus 2s are going to divide out, right? Because these are in the numerator. Here's the denominator. And actually, my x plus 2s are also going to divide out. Over here, I'm just going to have my x minus 2s are going to divide out. So therefore, I'm left with 3 times x minus 2 is equal to x plus 1 times x plus 2. Now, actually, in reality, by factoring this out, that really didn't help me out at all. So I'm going to multiply that back through. And I'm going to multiply this by using FOIL. So therefore, I get 3x minus 6 equals x squared. 1x plus 2x is going to be plus 3x plus 2. Now you can see that I have a rational expression. Or now I've simplified this, but now I have a quadratic. So remember, to solve quadratics, we've got to set it equal to 0, and then we can solve for x by factoring. So what I'll do is I'm going to add a 6 to both sides, and then I'll subtract a 3x to both sides. I don't remember that being my answer. So therefore, I'd have 0 equals x squared plus 8. I did this problem in another, I did this video, this problem in another video, and I don't remember getting x minus 2. X minus 2, let's divide out. 3x minus 2, right? 3x minus 2 equals x squared plus 3x plus 2. Okay, yes. Oh, okay, yes, I did. All right. So therefore, again, if I go ahead and solve this one, so I'll subtract for 8. Subtract 8. I guess I did get that answer. Negative x equals x squared. Well, I cannot take the square root of a negative number. So therefore, in this case, in this example, since you can't take the square root of a negative 8, this one is no solution. That's it. All right, so now get into the next one. Basically, again, we're going to find the LCD. In this one, you can see that the LCD, again, of all my denominators, I can rewrite my whole number. So it's as a denominator. I have x minus 2 times x plus 1. So my LCD in this case is going to be x minus 2 times x plus 2. All right, so therefore, I'm going to multiply. Now here, you can see my terms are separated by subtraction. So I only multiplied left and right these two terms, but when you're multiplying a whole expression, you've got to make sure you multiply everything by your LCD. So here I'm going to multiply this by x minus 2 times x plus 2. Over here, I have to multiply this by x minus 2 times x plus 2. And then over here, x minus 2 times x plus 2. Then again, using my division property, those divide out. Here, those divide out. And then here, nothing's really going to divide out. So I'm going to be left with an x plus 2 minus, make sure you follow your parentheses, minus an x minus 2 times a positive 3x. And then that's going to equal a negative 2 times x minus 2 times x plus 2. Whew, all right, so we're going to have some work here, some little bit of algebra we're going to have to do as far as simplifying this. So therefore, this becomes this x plus 2. Now remember, make sure you distribute your negative here. So when I distribute the negative and multiply by the 3x here, I'm going to be left with a negative 3x squared positive 6x is equal to, here, I'm going to multiply this negative 2 last. So I'll multiply this out. That's going to be a difference of 2 squares, which is going to be x squared minus 4. Distribute that. So let's combine your terms on the left side here. So I'll have a negative 3x squared plus 7x plus 2 equals negative 2x squared, negative 2x squared plus 8. OK, so now to go ahead and solve, again, I'm going to set them all equal to 0 so I can go ahead and factor. Well, I always like to have my quadratics be positive. So I'm going to add the 3x squared and solve for the x on the right-hand side. Therefore, I'll add the 7x on both sides. And then I'll subtract a 2 on both sides. So therefore, I end up with the quadratic 0 equals x squared plus 7x minus plus 6. So now I just need to determine what two numbers multiply to give me 6 and multiply to give me, or multiply to give me 6, add to give me 1. Well, that can be factored into x plus 6 times x plus 1. By using the zero product property, I can say x plus 6 equals 0 and x plus 1 equals 0. So therefore, x equals negative 6 and x equals negative 1. Again, I want to take those two solutions, plug them back in, make sure that they're not going to make either my denominator 0, which in this case they do not, so I'm good to go. All right, now into the last one here. You can see that in this last example, we only have one denominator. I don't think that was right, was it? Let me just make sure I wrote this up there correctly. Oh, 2x plus 2 divided by x minus 1. I didn't write the problem right. Sorry about that. Divided by x minus 1. OK, so now what we're simply going to do is, again, do the same process, but now we're going to determine our LCD, which in this case is going to be x plus 1 times x minus 4. OK, so now when we go ahead and get to this and we multiply, I multiply again every single term by my LCD, x minus 1 times x plus 4. x minus 1 times x plus 4 and x minus 1 times x plus 4. OK, so again, using our division property, our x plus 4's divide out. Here, nothing is going to divide out. And here, my x minus 1's divide out. Now, when I apply distributive property, I get a 6x squared minus 6x. Over here, I need to multiply using FOIL. So I'm going to have a plus 4 times the factored form of this, which is x squared minus x plus 4x is going to be plus 3x. And then 4 times 1 is going to be negative 4. Equals, then I also have this factor of 2x plus 2 times x plus 4. OK, so let's just rewrite this again. We're going to have some work here. Distribute this through. I have 4x squared plus 12x minus 16 equals, multiply this through using FOIL. You're going to have 2x squared plus 8x plus 2x plus 10x plus 8. Whew. All right, so now let's go ahead and get all of our variables to the same side. In this case, let's combine everything first. So when I combine them on the left side, I get 10x squared plus 6x minus 16 equals 2x squared plus 10x plus 8. I can either solve for the x on the left side or the right side. I'm going to solve for them on the left side. So I'm going to subtract a 2x squared on both sides. I'm going to subtract a 10x on both sides. And I'm going to subtract an 8 on both sides. Therefore, I'm left with an 8x squared minus 4x minus 24 equals 0. So now I just need to determine what two numbers multiply to give me or what two numbers are going to multiply to give me negative 24, add to give me negative 8, but not actually, I'm sorry. I got to determine what two numbers are going to multiply to give me 8, multiply to give me negative 24, and then them both multiply each other and go ahead and give me 4. So I'm actually going to erase, because I know that's going to be a little bit of taking some work here. So when factoring something like this, especially when you're doing this in your head, basically what I was saying out loud was we need to factor our trinomial. And we know that the first two terms have to multiply to give us 8x squared. So that could be 8x times x, or we could do 4x times 2x. But then we also need to determine numbers that are going to multiply to give us negative 24. So if you think of the factors of 24, we have 24 times 1, we have 12 times 2, we have 8 times 3, and we have 6 times 4. Now, since one of those numbers, since it's a negative 24, one of these factors has to be negative. But we're going to want to look back over here. And really, remember, we want to multiply our outer and our inner needs to add up to negative 4x. So if I'm factoring this in my head, I don't want to multiply 8 times 24. That's going to be too large. 8 times 8, too large. 8 times 6, too large. So really, 8 I'm not really seeing is going to work, except for 8 times 1 and 2. No, 8 times 2 and 12, though. 8 times 2 is 16. 12, that would work. So if I did a negative 2 and a, oh, I could have factored out. Oh, that would have worked. I should have factored that out earlier. That probably would have helped. Actually, not really. I still would have had that. But if I did an x minus 2, I'm sure I could have factored somewhere out there to help out. X minus 2, and then a plus 12. And let's see if that works. 8x times x gives me 8x squared, right? 12 times negative 2 gives me negative 24. The middle terms gives me 12x. That gives me negative 16x. Negative 16 plus 12x is negative 4x. Perfect. So therefore, I set them both equal to 0. So 8x plus 12 equals 0, and x minus 2 equals 0. So go ahead and solve. X equals 2. X equals negative 12 over 8, which reduces to 3 over 2. Again, we take our two solutions, plug them back in, make sure that they are going to work. And you can see in both these cases, they do not make our denominator 0. So therefore, we have solved all of our that we need. So there you go, ladies and gentlemen. That is how you solve rational equations. Thanks.